Good afternoon. My name is Dario Salinas. I'm a research associate at the French Institute of Geopolitics, and I'm also a member of Cartex, a consultancy firm specialized in geopolitical risk analysis. Today, together with my colleague Sofia Tirado from Elcano Royal Institute, I will present a study on water reuse in Spain and the US. Our focus is on territorial diagnosis and geopolitical analysis. The core of these works began as a private sector commission on risk analysis assessment in the water reuse sector. As we have said during the day, technical and financial aspects are essential, but they are not always enough to explain how reuse projects actually develop. This is why we also need to look at the territory with multiple dimensions and also the geopolitical context. In many water-stressed regions, reclaimed water is becoming part of a long-term water planning. This is especially clear in the Mediterranean and particularly Spain. It is also visible in other regions such as the American Southwest. Droughts are more recurrent, rivers and aquifers are under pressure, and conventional water resources are showing limits. However, reuse does not grow in the same way everywhere. This is the starting point of our research. Why do territories with similar water stress and with access to similar technologies follow different reuse trajectories? Our hypothesis is that technical capacity is necessary, obviously, but it's not enough. The viability and scalability of reuse projects also depend on regulation, finance, key actors, territorial priorities, and social perception of reclaimed water. This is why we use a geopolitical approach to understand how these factors and stakeholders interact in specific territories and how they may shape future reuse scenarios. The analysis drew on the French School of Geopolitics. In this tradition, geopolitics is not only about relations between states, it's a method for studying power relations and strategies of actors and their representation in specific territories. This approach is useful in the case of water reuse because reuse projects depend on who controls resource, who defines the rules, who finances the infrastructure, and how reclaimed water is perceived. The method begins with multi-scalar and spatial reasoning. It reads territorial configuration across international, national, regional, and local basin scales. It also looks at how physical, social, economic, or political layers overlap. These layers do not always coincide, and their overlaps help explain where tensions, opportunities, or blockades may appear. On this basis, the analysis connects spatial conditions with power rivalries between actors and their own representations. Public authorities, utilities, farmers, industries, investors, or environmental groups may represent reclaimed water in different ways, as a secure resource, a risk, a cost, or a tool for climate adaptation. Cartography is also part of the method. Mapping helps make territorial complexity more visible. This is important for geopolitical risk analysis because wastewater reuse risks do not appear only at the national level. They often vary between basins, regions, or municipalities. Indeed, it helps identify territorial signals that can block, slow down, or redirect reuse projects. The first case, the US, the map shows a clear paradox. The country has significant water reuse capacity, but reuse is deployed very unevenly across the territory. There is no single national model. Reuse depends on state regulation, basin conditions, utility capacity, and the geography of demand. A large share of reuse activity is concentrated in states such as Florida, California, Texas, Arizona, and Nevada, but these states do not follow the same logic. For example, Florida is one of the large users of reclaimed water, but its model is not mainly driven by climatic conditions. It's linked to urban growth, pressure of aquifers, saltwater intrusion, and the protection of sensitive ecosystems. In the Southwest, the logic is different. Reuse is more directly connected to scarcity, water rights, and allocations. This is especially visible in the Colorado Basin, where Nevada and Arizona show high level of reuse compared with many other states. In these cases, reuse is supported by a strong and concentration metropolitan demand, large utilities, and the need to secure water for growing urban areas. This fragmentation is also institutional. The environmental public agency provides guidance and coordination, but reuse regulation depends mainly on the states. As a result, some states have moved faster, especially in advanced reuse and potable reuse, while others still have less developed frameworks. There is also a strong gap in capacity and finance. Large utilities can develop major projects such as Pure Water San Diego or El Paso Pure Water Center. By contrast, more than 90% of community water systems in the US serve 10,000 people or fewer. Many of them do not have the same financial or technical capacity to develop advanced reuse projects. In the US, also shows an emerging strategic dimension of reuse. In some regions, industrial growth is adding pressure for secure and predictable water supplies. This is especially relevant for data center, artificial intelligence, semiconductor manufacturing, and other advanced industries. Coming back to Spain, in the European context, Spain, as we said, is one of the Europe's leading reuse countries, but the national pictures also hide strong territorial differences. In Spain, regulation comes from both the European Union at the national level. This gives a common legal certainty, but it also increases the importance of monitoring, compliance, and institutional capacity. Implementation is also shaped by regional and river basin authorities. Territorially, reuse is highly concentrated. Most reused water is located in the Mediterranean regions, the islands, and large metropolitan areas where climate pressure, irrigated agriculture, tourism, and urban demands overlap. Murcia, as we have seen, is the clear example of reuse integrated into regular water management, especially for agriculture. This concentration is also shaped by regional priorities, investment capacities, and water governments. Spain is a decentralized state, and water management involves rivers, basin authorities, autonomous communities, municipalities, utilities, and irrigation communities. In the recent decades, water debates in Spain are therefore highly territorial. The Tagus Segura transfer is a good example. The debate around ecological flows in the Tagus increased the strategic value of non-conventional resources, especially reuse and desalination in the southeast. Climate change reinforced this pattern. It reduced the reliability of conventional resources and made territorial imbalance more visible. Reuse and desalination become strategic resources, but they don't remove the political question of who receives water, under which rule, and at what cost. This table summarizes the comparison between Spain and US. I will not go through each category in detail, but scarcity creates pressure, but it's not automatically create viable projects. Reuse grows when treated water becomes an operational resource, when it can be connected to the real demand, existing infrastructure, institutional capacity, financial, and social acceptance. This is where geography at micro and regional level matters. In the US, reuse develops within a federal system where regulation depends mainly on the states. This can support innovation in places with a strong water pressure and large utilities, but it also creates fragmented trajectories between a state and between large metropolitan systems and a smaller water system. In Spain, the European and national framework gives a more common regulatory basis, but a common framework does not produce uniform implementation. Reuse still depends on national and regional dynamics. The political geography of water is also different. In the western US, reuse is linked to water rights, return flows, accounting rules, and allocation debates. In Spain, it's linked to public domain planning, concessions, basin authorities, and conflict between regions and water uses. In conclusion, the main idea is that reuse planning does not end with treatment feasibility. A reuse project depends on multiple dimensions. These dimensions shape where reuse can grow, where it may face obstacles, and what role reclaimed water can play in the water system. This is why territorial diagnosis is useful. It connects technical feasibility with actors, rules, and expectations. It helps identify what resource may replace, where tensions may appear, and which actor may gain or lose influence. Indeed, this diagnosis is useful for different actors. For governments and basin authorities, it supports more realistic reuse strategies. For operators and utilities, it helps assess projects beyond treatment technology, including water quality, salinity, or energy cost. For investors and industrial users, it helps understand reuse and infrastructure exposed to regulation, allocation security, political risk, and future compliance cost. Seen in this way, the geographical and geopolitical reasoning does not replace technical or financial, economic, or regulatory analysis. It complements them. It adds the context that feasibility studies often leave out. Thank you very much.